Welcome back to our last lesson for this week of our first week of our online learning, lesson 68, finding conditional probability. Now, we've worked with probability questions a number of times already this year. We know that probability is the likelihood or the chance that something's happening. What format did we always write probability questions in? They were fractions, and we'll be doing the same thing in our lesson today. Now, to review something we talked about before, and then we'll get into our new part of the lesson today. Independent events. What does that mean? That things are independent, they can stand by themselves. So two different things are happening and they do not affect each other. So I'm going to roll the dice on my game and I want to get a 3 the first time I roll it, then I want to get a 5 the second time. Well, those two things don't affect each other. Just because I got a 3 the first time doesn't mean I can't get something the second time. So it's two unrelated events in our question. When we had to do the probability of these independent events, all that we simply had to do was multiply each of the individual probabilities together. So like in my example, what's the probability that I roll and I get a 3 first? Well, only one of the sides says the number 3, and there's 6 different sides on the dice. So I would have 1 out of 6. Then I want to see, okay, what's the second thing that I want in the question? And that was the number 5. Well, one of the sides says the number 5, and there's a total of 6 sides that we have on our dice, so 1 out of 6. So I would have 1 over 6 times 1 over 6 for my final answer of 1 over 36. The other kind of probability questions that we've talked about before are called dependent. Well, independent were things that did not affect each other, so dependent are events that do affect each other. There's some sort of relationship between the two things that are happening. Usually with these ideas of the dependent events, it involves you picking something and then you didn't put it back. Well, if you didn't put it back, then you have one less option as you go to select the next thing on your question. So let's go ahead and try one of these examples together about this dependent event. So I'm looking for 3 baseball caps and I'm going to choose them at random and I'm not going to replace them as I go to select them. In our box, we have 6 tan, 8 gray, and 9 black, and also 12 blue. So my job is to find the probability that I'm going to get all 3 hats or all 3 caps are going to be gray. Well, currently I have 8 gray, so that's how many possibility I can have in this question over the total number of hats that we had. So if I add 6, 8, 9, and 12 together, I'll get a total of 35. So my first fraction is 8. How many ways could it happen over the total of 35 hats? Well, there's multiple things that I want to happen, so I'm going to be multiplying together in our question. Now, notice for the second fraction, I'm down to 7 over 34. Why did the numbers change? Well, because I didn't put something back, I have 1 less to choose from in the question. I originally had 8 gray hats, but I just took 1, so now I'm down to 7. I originally had 35 hats. I've already taken 1 out, so therefore I'm down to 34 in the question. And the same thing is true about that last fraction. I'm down to 6 gray hats out of a total of 33 hats that I have in this question. I have all 3 fractions written down, so I'm going to multiply them together, and I just did that on my calculator, and my final answer gave me 8 over 935, and I just turned that into our percents. You can see it's probably not going to happen. It's less than a 1% chance that it's going to happen that I would be selecting all gray hats for these 3 selections in our question. So those are the kind of questions that we've talked about before with regard to probability. We'll still be following the same concept of a multiplication question to help us come up with some of our final answers. Now, in the lesson today, we're talking about this idea of a conditional probability. So what does that mean? You have a conditional probability, the probability of an event given that something else has already happened. So I mean, it's kind of the same idea as the dependent, but there's just a couple slight differences between these two things. So I'm going to say I want the number 3 first. That is the only thing that can happen in the question. And then there is a second thing that's going to happen in the question, but it only can happen if the number 3 happened first. Something had to occur first in the question before something else can happen for the second thing as part of our probability question. Now, the notation that our textbook's going to use for these questions looks like this. It says capital P, which stands for probability of B, and then it has that dash. That's such that, so something's occurred. So the probability of B, or the second event, such that A has already happened in the question. So something must happen first before something else can happen in our question. The probability format that we're going to follow is once again our multiplication question. So the probability of this happening and this happening, you're going to do the probability of the first scenario just like we've always done. Now times what's the probability that the second thing happened given that the first thing did actually occur on our question. Okay, so I have about 4 different examples that we'll try to walk through together to see if we can understand this idea of a conditional probability. Please make sure you go ahead and write this information down. So if you need to pause the screen here, so you can write this down, as I'll be using this to help us on the next couple questions. In our box here, in our bag, we have 5 different numbers. So 1, 2, 3, 4, 5. It says I'm going to draw a number, I'm going to put it back, and then someone else is going to draw a second number. The first scenario that we're looking for, I want to know what is the probability that the first number that is drawn is the number 3. Well, we know how to do that. And then here's just a little bit different things that we've seen before. The second thing in the question says the sum, which we know the word sum means to add, the sum of the numbers is greater than 5. Okay, so this is how I would encourage you to work through these probability questions. You kind of want to write out or draw out what's happening on the question. So what's the first thing that has to happen in this question? It says the probability that the first number is 3. So as I'm going to list out my problem here, the 3 is going to be the first number that I'm going to write down. Now, the second person can come in and they can pick any of the numbers that are still inside of our bag. Well, what's inside there? 1, 2, 3, 4, or 5. So here's the options that it could happen in the question. Notice my first column is all the number 3 because the first person has to get the number 3. That was the only option. The second column represents my second person. The second person could have got any of the 5 numbers. So I could do 3, 1, 3, 2, 3, 3, 3, 4, or 3, 5. Those are all of the scenarios that could have happened in our question. Now, what was the condition in this question? It said the first person had to get 3. What's the second thing that I want to happen? It says I want a sum that is greater than 5. Well, if I look at each of the columns here, well, the first row, 3 plus 1 would give me a sum of 4. 3 plus 2 is 5, and so forth down to get our 6, 7, and 8. Which one of those has a sum that is greater than 5 is the last 3 that I put a check mark by. So now I've kind of visualized what's happening in the question, and I can go ahead and write down my answer for probability. Well, there's 2 things that were still happening. What are the 2 things that I'm going to be multiplying together on this question? The first person came up, they had to get the number 3. Well, in the bag, there were 5 numbers, 1, 2, 3, 4, and 5. They only could get one of those numbers, so the first probability is 1 over 5, like we're used to writing. Now, times was the second thing that I want to happen based on the condition in this question. The second thing said the sum had to be bigger than the number 5. Well, how many total sums did I just write on our screen? 5. I had the sums 4, 5, 6, 7, and 8. How many of those met the condition of this question? 3 of them. So my second probability fraction is 3 over 5. So the first fraction, 1 over 5, because 1 out of the 5 numbers said the number 3. The second fraction, 3 over 5, because 3 out of the 5 sums that I'm looking at here contained the qualification that it was bigger than the number 5. Finish multiplying those together, and there's our final answer that the probability is 3 over 25. Let's use the exact same scenario in our question that we still have those numbers 1 through 5. Let's go ahead and look at this question. I'm supposed to answer what is the probability that the first number is going to be odd, and then that the product of my 2 numbers together is going to be an even number. Okay, so here comes person number 1. They need to reach in and they need to pull out an odd number. Well, the numbers that I have are 1, 2, 3, 4, and 5. Which one of those numbers are odd numbers? 1, 3, and 5. So I'm going to be listing out 3 different columns here on my screen to represent what the first person can do. The second person is going to come up and they could have picked any of the 5 numbers, and then we're going to look at their products together. So here's the different scenarios that could happen on our question. Notice my first column, person number 1 came over and they selected the number 1 because that was an odd number that we had. Column number 2 over there is the numbers 1 through 5 because person number 2 could have picked anything. The second column that I have on the middle of the screen, person number 1 picked the number 3. Well, that's a possibility because it said they had to get an odd number, and 3 is an odd number. The second thing next to that, again, is the numbers 1 through 5, because person number 2 could have selected anything that was left inside of the bag, and all 5 numbers were there. The third column, person number 1 gets an odd number. Well, what's the other odd number that we have? 5. Person number 2 could have picked anything, so I have 1 through 5 next to each of those numbers 5s. Now, what condition are we looking for on this question? It says that their product is even. What's the word product mean? Multiplication. If I multiply each of those individual combinations together, which one give me even options? The ones that I've check marked on the screen. So what is my answer for the probability? The first situation, person number 1 had to get an odd number. In our bag, there were 3 odd numbers, 1, 3, and 5. So I have 3 in the numerator out of the total of 5 numbers that were there originally. Times, what's the second scenario based on the condition? Well, the condition was the first person got an odd number. Those are the ones I have listed up here on the screen. Which one of those had a product that was an even number? Well, I have 6 things check marked, so that's in our numerator, and there's a total of 15 different combinations that we've written on the screen. So 6 out of 15. Well, if I'm going to multiply those together, I could come in here and reduce first. Of course, my calculator would help me with this as well. I can reduce with my 3 and 15. The 3 would cross off, and my 15 would become the number 5, because 3 and 15 both divide by 3. Now, if I multiply those together, my final probability is 6 over 25. So I think it's going to be very helpful for you guys if you list out the options like I've shown you up here on the screen, and then just check mark what do you see is actually the scenarios that you want, and then that will help you write down your 2 different probability fractions to multiply them together. I'm going to go ahead and stop my video now, and then we'll pick up with the second part of this lesson for you to watch.